delighted this afternoon to host our session on transforming the fabric of our built world, where we're going to explore circular and sustainable materials and processes in development to support the journey to net zero. Just before I introduce the speakers, there should be a poll. Yep, is that on there? Fantastic. So that will be up, and I would encourage you all to fill that in. How are we going? What, 4 people? Yep, but carry on doing that. So we've got 3 fantastic speakers for you this afternoon from 2 organisations, from Zero Waste Scotland and Kenoteq. So without further ado, I will introduce our first speaker, which is Stephen Boyle from Zero Waste Scotland. So Stephen is a senior member of Zero Waste Scotland's Customer Engagement and Communications team. He oversees the provision of a variety of support services to public bodies, private businesses and third sector organisations. His focus is on the construction sector, supporting the industry to embrace a more circular approach to use materials and different ways of working. And Stephen's team support construction businesses adopt and evidence the benefits of action that keep materials in high value use for longer. So Stephen has worked in the environmental sector for 30 years, and prior to joining Zero Waste Scotland, he has built up significant experience working within Scotland's environmental regulator. So Stephen is going to join us to speak about consumption and its impact on net zero and how material choices can make a difference. So over to you, Stephen. Thank you.
Thanks very much, Jen. Hi, everyone. I've already been introduced, so I don't need to do that. So I actually got quite a simple message for you today, and I'll go through it and I'll say it at the end. It seemed to be a bit strange coming in here to a simple message after all those technical presentations you've just had, but hopefully I'll give you some information and then get to that little message just at the end. So, down the way. Up the way. Oh dear, this is good. No, right. Okay, right. Okay, so Zero Waste Scotland, for anyone who doesn't know, we're a non-for-profit business fully funded by the Scottish Government and European Regional Development Fund. We're here to promote resource efficiency and the circular economy in Scotland. And of course, as well as that, delivering net zero carbon as well and reducing carbon. So I want to talk to you about consumption, because consumption is one of those things which has actually been missing a little bit missing from the COP discussions. The waste industry are also saying that waste is also being missed out in the conversation, but they are very, very much related because they're all about materials and products and what they actually mean in a carbon perspective. So let's look at consumption. Globally, consumption is around about, well, it's actually over 100 billion tonnes of materials. But really significant to that is the fact that only about 9% of that is actually recovered for reuse. And that's something that we really need to address, especially when you heard Terry this morning talking about the fact that Scotland lives in a 3-planet society. We need to address the recapturing of materials and gaining the benefit of those materials within our society and, today, the built environment. So in Scotland, we did some, no, this is the Scottish Government work from 2017, we use about 100 million tonnes of materials in Scotland in a year. That equates to about 18.4 tonnes of resources each. Now, if you actually look, depending on when you actually look at, but sustainability-wise, we should be looking at about 8 tonnes per person. So we are definitely using more materials than the actual Earth can actually supply. So what was it Terry said this morning? We've got a broken model. But as well as that, we know the impacts of the construction sector. And we know that the construction sector in the UK uses about 50% of all the resources by weight that we consume. And we also know, from the Scottish perspective, that 82% of all Scotland's carbon footprint comes from material use, consumption. So it's massive. So what we're talking about here is a big figures and an opportunity to make big savings and really help with the net zero agenda. So this is just a slide. This is one of the 3 definitions from the UK Green Building Council on net zero, and it talks about whole life carbon. But they make a very important point about buildings going forward in the future if we're going to meet net zero. Yes, we need to tackle operational energy, and to do that, decarbonise the grid and reduce the amount of energy, reduce demand, reduce consumption of energy within our homes. But we also need to use sustainable materials, natural materials which sequestrate carbon, but also reuse the materials which we've already got in our built environment now and utilise them for valuable products, retaining the value as much as we can and reusing them in our buildings to meet net zero. And we need to do that. And even when we do that, by the time we get to 2030 or 2050, whatever target you want to look at, we will probably need to offset as well. And I'll show you why. So it's all about material choice. Now, a nice way of visualising that for people who don't look at it are these material pyramids. When we do analysis for working out whole life carbon, embodied carbon of a building, we use called the ICE database. And that's a UK-based figures for embodied carbon. But this is a very nice visual way of seeing how much embodied carbon was in the materials that you use in the building, with natural, sustainable materials at the bottom and your metals and steels at the top. I think someone mentioned earlier about how much materials are, and I'm talking about in a UK level, 82% I mentioned there, but cement, steel, they all contribute something. The main 4 materials, aluminium, steel, cement, they actually contribute to somewhere in the region of about 12% of the global carbon footprint. And the majority, and that's the materials that then go into the construction sector. So I've taken one of these pyramids and I've given you a link there to a Danish pyramid, which is really accessible, and I've used the figures from that for today. But as I said, I usually use it, when we use one of these things in the UK, we use the ICE database. So this is just about the impacts of materials and material choices you put in your building. This is structures. So if you take a structure, you take structural steel, and you put that into your buildings, per cubic metre of CO2, that wasn't me. For structural steel, if you put it into a building, cubic metre of CO2, it's nearly about 9 tonnes. It's 9 tonnes of carbon, embodied carbon within that material. Now, if you choose to do something different and you choose some concrete, the concrete in that frame is much lower, about 288, but of course, concrete frames have rebar in them as well. So the number is north of that figure. But say we don't, say we actually start looking at natural, sustainable materials for our structures, similar to the ones that Matt has been talking about today, then their cubic meterage of CO2, because the wood absorbs CO2 in its life cycle, they actually have a negative or a positive, depending upon the way you look at it, impact on the embodied carbon of the building. And as you can see there, structural timber is about 680 kilograms of CO2 per cubic metre. CLT and glulam, they're about 600, so slightly less, but still a negative sequestration of carbon. 2 other examples. This one's insulation. We have wood fibre, glass fibre, and PIR. PIR insulation is the normal stuff that you see with a metal backing on it. And so the PIR insulation, same weight, cubic metre, is about 781. Much reduced is glass. Recycled glass being put back into glass wool reduces the impact dramatically. But again, if you use natural, sustainable sources of materials like wood fibre, we begin to see the sequestration of carbon and how low it can actually go. A very quick one on fired bricks. I threw this in because of Gabi. Hi. Just so that you can tell them yourself about the fantastic product you've got. So fired bricks, about 528, that's half a tonne per metre cubed. I think Double-fired red brick, which is most of the brick you see down in England, they're about 800, 900 per brick for each metre cubed. So a little bit higher for those. Concrete's lower, but aerated concrete's lower, but you reuse bricks, which is really important. We reuse material. And one of the main factors for doing that is the fact that it's got so much less embodied carbon. So if we can reuse the product and really value them for what they were made for in the first place, we really can make an impact on net zero. Now, this is an example. We did a whole life carbon study on a small housing estate in the north of Scotland. And I'm sharing this with you just to make a couple of points. When we do a whole life carbon analysis, we actually don't count the sequestration of carbon as part of the embodied carbon footprint. We look at that afterwards. But here we are, we have a wooden framed building using natural materials, and it still doesn't meet the embodied carbon targets set out under the LETI guide for 2025. Now, once we take the sequestration of the carbon in the wood, yes, we do. And we've got a minus 105 there per metre squared. But that also shows that if we are putting targets in place for embodied carbon in our buildings, that the only other way that we can actually reduce our embodied carbon is that you must reuse those materials that we currently have in our building stock. And that's the point of showing you that graph there. There's many examples, some old, some new, of buildings around about Scotland and around the world who have reused materials within their structure. The building there on your right is a fantastic one that we can talk to you about, Ours for Circular Economy and the approach to circular economy, but I'm not talking about that today. But by all means, go and have a look at it. It's a building which has been built modularly to be taken down, rebuilt somewhere else, and repurposed at any time in every piece of material, and it can be revalued, reused. So that's the type of thing which we need to actually look to do. These are, again, are two examples of buildings that have been made from recovered materials and natural materials. The one in Butte has an absolutely beautiful window made of bottle bottoms. So if you ever get up to there, go and have a look at that recycled. It's got an absolutely fantastic window. And of course, can't come to the factory today with all of these demonstrations without mentioning the fact that you can build big in CLT. We just need to take the dive and go for it. And that's a perfect example in Elmsley Road of a 7-storey residential building made of CLT. Now, I'm going to share this one with you. This is a design that we have just completed. Hopefully this video will start and the music won't play, so you don't want to drown me out. But this is an example. Yes, this is a community building up in our Arbroath area of Scotland. We've just finished the designs of it. It incorporates 92% sustainable or reused materials in its design. In its design. It uses cross-laminated timber, hopefully Kenoteq brick, McRuber, plastic road surfaces, as they like to call them. But it uses all of these materials to reduce the embodied carbon impact of the building, to make it a sustainable, low-energy build. And it is possible, and that design proves it. And this is just one last slide, just to say that there's a number of companies in Scotland who we've worked with who are producing sustainable materials using reused materials from the built environment and the surrounding environment to take what is people's waste and turning them into valuable products that we can use within the construction sector now. And there's lots of stories behind every one of those. And you're going to hear about one of them now. Thank you.
Thank you, Stephen. I can't believe that, 18 tonnes per person, and having to reduce that to 8. That's quite a significant reduction in consumption for each and every one of us. And also fantastic to hear about all the different types of buildings, really putting materials at the heart of their design to reduce the overall embodied carbon of that building. So talking of materials, we will now move on to our next company, who's Kenoteq, and we have 2 speakers for you just now. We have Sam Chapman, who hails from the Lake District. Dr. Sam Chapman, he relocated to Edinburgh in his final years of school. He holds a Master's in Structural Engineering with Architecture Design and a PhD in Carbon Assessment of Wind Power. When the opportunity arose, he took the chance to work on the development of a new type of building material, and the rest, which we're just about to hear, is history. So Sam is now the Managing Director of spin-out company Kenoteq Limited, and Kenoteq's patented K-brick is an unfired brick made of 90% recycled material. Hopefully you've all seen it as you came in. The K-brick is made nearly exclusively from waste material and boasts the highest recycled content of any building material in the UK. And Sam will be presenting alongside Gabriela Medero. Gabi is a civil engineer that moved from Brazil to Glasgow almost 20 years ago to undertake her PhD studies at University of Glasgow. And after that, moved to Medero University, where she is a professor of geotechnical and geo-environmental engineering and leads the research on sustainable, innovative building materials. The K-brick was born from her passion and drive to help the construction sector to protect our natural resources, boost recycling and reduce emissions. Put my teeth back in. So I will welcome both Sam and Gabi to the stage. Thank you.
Thank you. Can you hear me? Yes. I was going to take the coat, but I'm too cold. I got used to work from home with pajamas. Now to dress is too hard. So thank you very much to the Innovation Center to invite us to talk today. We're in very good company. We're really enjoying to see all the drive of so many people in the right direction and to have an audience here of people that care, and that's why you're here. So that's the moment more than ever that we need to join forces and go in the right direction. I hope when you arrive here and when you enter in this part here, you looked your left, and I hope when you looked your left, you had a nice surprise of seeing the K-brick there. So Sam and I have been through a long path to get today here with some very supportive partners that I must say that one of the very first ones was Zero Waste Scotland and the Innovation Center. And it has been a very long journey, but it's great to be at this point that more than ever we need to be doing something in the state that we can use the K-brick. So I'm going to tell you a bit of how we reach where we are. Oh, many buttons here. Okay. The right direction. So starting here, talking a bit about the challenges that we face and face for some time. And I always see any challenge as an opportunity more than anything. And for us, when we think in terms of bricks, the first thing we think is the market and the bricks, what is available out there. And there is a shortage of bricks, and in the UK importing 500 million bricks per year in 2019. And here in Scotland, scary the number, 85% of the bricks used per year are imported. And when I say imported, it's not just coming from down south, it's coming from places as far as Ukraine. So it's not only the fact that bricks are very, well, we saw the number in terms of the carbon there, but it's also the logistics and the carbon of moving these heavy materials around the world. Another very important challenge, a target that is a great opportunity that we need to take into consideration is the house building targets. the UK has agreed to deliver over 300,000 new homes per annum for the next 5 years. We need materials for that. We don't have enough materials. There is imbalance there. We need to be producing more materials, and there is something that we have heard already today here, and we need to be seeing how we can do this locally. We cannot be going for things that are the other side of the world as option. And as always, we need to be very aware of legislation. And thankfully, we have legislation in place and more to come, that now 70% of all construction waste to be recycled and 0 to be sent to landfill. Finally, and more, we're going to be seeing things also being looked in terms of resources and natural resources, because we cannot continue just taking material from the ground. So there is more and more discussions of legislation in that direction too. And the environmental impacts. I was listening before saying the largest contributor of carbon emissions is the built environment. The latest statistics is saying that 45% is coming of the emissions is coming from built environment. That's not right. We cannot continue in that way. We need to do something, and there are many things that we can do, and every little thing that we do makes a difference. So we need to get more and more information, what are the options and how can we implement that. And very scary number that construction demolition is the largest contributor of the waste around the globe and in the UK in particular. And setting up a bit of the market, I mentioned already of the 500 million shortfall of bricks that are used for new housing, for commercial, for renovations. This 16% of growth in green market, and hopefully we'll see this growing faster and faster. And the new 1 million new homes in 3 years, and how can we deliver that, considering that we are now moving to net zero? What are the options there? So I'm going to talk a bit how everything started. I'm going to leave this because I'm going to end up throwing away because I move my hands. So what is the K-brick? So now it's more than 10 years ago, I start getting more and more bothered with how we deal with our environment. My background, civil engineer, geotechnical engineer, I really give value to our natural resources. What kind of natural resources? I'm talking about sand, clay, gravel. And we have been exploiting, removing this from the ground years after years. We know now there are many locations that we have been extracting, exploiting our natural resource for so many years now have finished. And we have then suddenly, everyone is surprised that we have more flooding, more erosion, unbalanced ecosystems. Not a surprise. We have been removing from the ground. We're paying now the consequences of that. So with all that in mind, and being very aware of the numbers, what we're doing in terms of production of waste, carbon emissions in the construction sector, I started thinking, how can we produce something reusing waste coming from construction demolition? So I had the concept much before of the fashion now of circular economy, but I had the concept in my mind of, can I take waste from construction demolition, recycle that, make it into new building materials that go back to site? And that was the idea and the principle behind the K-brick. And this is what happened. So years and years of research, a lot of mistakes, lots of wrong samples and things that didn't work. But we learned a lot from what it didn't work with also what it worked. And we came up through this process with a brick that is made of over 90% recycled construction demolition waste that doesn't have cement in the mixture. Very important from the very beginning. I didn't want to be linked with cement. Cement, if it was a country, would be the second one in terms of carbon emissions. So no cement in the mixture of the K-brick. And another important thing we wanted to change was the energy for producing that. If we think in terms of fire clay bricks, we require temperatures of 1,000, 1,700 degrees Celsius, depending on the application of the brick. That's not viable. We cannot. So it was necessary in our process of developing the K-brick not to have any firing. And we managed. We got there. And, well, you can see there, we have a wall just next to us here to see. The key thing on that is, first of all, resource efficiency. We're not exploiting natural resources. We don't want to do that. So we're reusing recycled construction demolition waste. Second important aspect here, the carbon emissions. First of all, the energy demanded to manufacture the K-brick is just 1/10 of traditional fire clay bricks, and with that we have 1/10 of the carbon emissions. And as we scale up now our facilities, that it is happening now for early next year, we have already predicted that this is going to even go down the numbers drastically because we can optimize things as we have larger scale. So that was the concept. And then I put here closed loop. What is this closed loop? So we have a circular economy product for sure. But I'm not thinking just, okay, today, very short term. We need to think now in solutions that are long term. And when I say long term, I don't want to have a solution that my kids and my grandkids are going to be suffering. I made a promise to my kids that I was going to leave a better world than when I arrived. And I'm taking that serious. And what I say is that, so with that in mind, when we're developing the K-brick, we're thinking, so what's your favorite color? Green. Okay, nice choice. So let's say we build a building with green bricks, all facade green bricks, because he loves green bricks. I like green too. We're all good. But 60 years from now, his grandkids come and they say, we hate green. We don't want a green building. We want a blue building. Fine. We demolish that building. We recycle that material. Let's go back to our circular economy. And we use that same material as feedstock to make our new blue bricks that go back to site. So we're not thinking just today, we're thinking tomorrow. The buildings need now to be thinking, not this generation, the next, many generations to go. We're not producing more waste. We're not extracting more natural resources. So that's the closed loop circular economy that Kenoteq is pushing. We want to change how things are done, and we want to have this long-term thinking on the environment, long-term solution. So this is the K-brick, is a closed loop circular solution in terms of building materials, and I have here. So low to zero carbon products is our target. We are entering the market now with the K-brick, and through this long journey of lots of mistakes and lots of good findings, we learn a lot, and we have been now developing a portfolio of other products that will enter in the market with different applications, but all aligned with our ethos of having zero carbon and some thinking maybe negative carbon to come with man-made products. And it's very important that we keep that, and this is the heart of the way we approach construction for the future. And we have been looking at circular models for the K-brick and any other product that will going to be entering the market. We have also the flexibility that it is true, we can make green bricks, because sometimes I get an email and say, is it true that you can make pink bricks? Yes, it is true. We can make pink bricks. And at the moment in Dubai, they are building part of the solar decathlon a magenta part of the building with K bricks because they wanted specific magenta color bricks. So it's also changing the way manufacture is done, because fire clay bricks now, they're extracted next to the extraction, they are manufactured next to the extraction of the clay. So not in areas of demand of bricks. So you have this movement around, again, of very heavy materials, increasing the carbon with these logistics of the materials. We have a different model. What we want to do, we want to have manufacture of the K brick next to areas of demand. We're starting here in Scotland, just outside Edinburgh, next door to a recycling plant. So I recycle the construction demolition waste in one shed. Next door, I manufacture the K brick. I have big trucks coming with waste. I have big trucks leaving with bricks. So we are looking at much more than just a material, but it's a model, as a different way of approaching construction, and where we can reduce carbon emissions, we're gonna be reducing the carbon emissions, and where we can be more resource efficient, we're gonna be doing that. How we can do that? We are a spin-out company of a university, and we have all the background in terms of knowledge and the support of capabilities of a massive lab to test from a tiny little sample, because before I make a brick, I normally start with tiny little samples, literally. Then we go to cubes when things are looking a bit more promising. And then when we start producing our first bricks, okay, things are getting more ready. And for years, Sam and I used to walk around with our bricks as we're carrying our babies. And I remember years ago, we were in a meeting and an architect took a brick and just did like this. And of course, as you do with any brick that you, after you just leave to fall free, it broke. And I remember that I had to hold myself, saying, why did you throw the brick? I wanted to see if it breaks like a brick. It does break like a brick. It behaves like a brick. It performs like a brick. And the whole magic is, and you have seen in the wall there, it is just a brick, but with a lot of science and technology to know exactly what it is there and how it behaves, how it performs in the most extreme conditions. That is the standard, but there is no better place to develop such a product than Scotland, because at the same time that we're being freezing and boiling bricks for years and years, and then after destroying them, we're leaving bricks to the weather. Just outside in Scotland, here you're gonna have in a day all the seasons a number of times and exposing them to cycles of temperature that couldn't be better test than that. So this is the K-brick, and this is where we are. Sustainable material, no firing, just 1/10 of carbon footprint, and actually it's gonna be less than that with now our new facility. And it's the first really product in the market with such high content, and for us very important that we add value. Something that we heard today more than once here is that we add value for a use of a material that has recycled material. And what is the recycled material of the K-brick is all this inert waste coming from construction demolition. That is gravel, sand, gypsum from plasterboard, that we know we are used with that materials. We have been living with them for many years. We know that they don't change. And we are adding value for that and reusing that, because the last thing we want is to them to end up in a landfill or not having a good use for it. We have a patent that is granted in the UK and US, and in the latest stage with Canada and Europe. We are moving now to our first projects, and it's very exciting. It's lovely to see the wall. And I'll pass to Sam, my business partner, and to continue talking more about the product.
Thank you, everybody. I'm keenly aware that I'm the last speaker, so I don't want to take too much of your time. But Gabi set the scene perfectly in the history and the development of Kenoteq and indeed its first product, the K-brick. And really I want to now talk briefly into the future and really what the impact that I feel we can make. And just this photo, this alludes a bit to the pink brick that Gabi mentioned, and also that you will see over in our demo wall. We can truly make nearly any color using recycled pigments, and so again, these are not virgin materials. These are recycled materials that we also use for some of the more interesting details, the aesthetics. This is just a brick, but we want to excite and encourage specifiers and architects into the future that you can really do something exciting with our product. And it's revolutionizing bricks. You know, traditional bricks are the color they are because of the minerals in the soils and from where they're located. Our brick can be made into any color that the designer might want, or indeed the planning restrictions may require. We make it currently in a standard UK-sized brick, but again, we can make many different shapes and sizes. So I'm hoping I'm whetting the appetite of some of the designers in the room. And again, this is just some photos just to allude to this excitement and some of the, we're two engineers, but we want to excite some of the designers and architects in the room. And indeed, in the middle here is a brick slip system. So not just, don't just think about full bricks. Think about some of the new smart generation homes, modular homes we've already heard about today. We want to move with the future and really innovate in a very, very traditional space that is, traditional brickwork. And indeed, our pigments, our colors are not just on the surface of products. Even in traditional clay bricks are often just colored. This is throughout our product. This is one of the more wackier bricks that we've designed that ended up in the Design Museum in London, where we're also currently part of the Waste Age exhibition there, which is there for the next 6 months. So if anyone's in London, please also go and see some of our exhibits there. And we're next to Stella McCartney for fashion, which is quite a surreal experience for a couple of engineers and brick developers. And just again, alluding to some of these other photographs, this isn't just, we're not just a one-trick pony, we're looking at a few different products. Can we start replacing cement? Can we start replacing concrete blockwork, aerated concrete, and other kind of construction units that are out there? Just briefly, this is sort of part of our strategy, and I want to kind of allude to a quick few figures, and obviously Stephen very, very nicely set the scene in terms of embodied carbon. But we're currently entering the market and we're installing our new facility, which again, very kindly, Zero Waste Scotland have helped support that. And by next year, we hope to have the capabilities to be making over 2 million bricks a year and hope to at least impact and make 1 million bricks next year. And that equates to about 2,200 tons of waste. So that's been avoided from landfill and that's been moved out of the waste stream. And indeed, our demo wall, which you'll see on the entrance, that's 2.2 tons of construction waste that otherwise would have had to be reprocessed, put into landfill, or into low-grade applications. So we don't want you to just see this as a brick. This is storage of recycled waste. This is use of a resource. And indeed, cities are the mines of the future. We're done with mining raw materials out the ground. Why not look to our cities and our current built environment for really bringing innovation into new projects and new builds? And this is our vision for the next couple of years, and we hope to be hitting a sort of 10 million a year brick target in the next 4 years. And the only way we can increase that is with the help and support of developers and people willing to use our bricks. So again, I would extend that olive branch and please speak to us about using the K-brick both in demonstrators and indeed into future projects that are coming online. 10 million bricks, again, this equates to, this is about 220,000 tons of material that you would be storing. And if this was 10 million clay-fired bricks, by using the K-brick, you're in essence, you're removing 5 million kilograms of CO2 that would have been emitted by producing those clay-fired bricks. And I know these numbers don't always relate directly, but just sort of an approximate, that's a Boeing 747 flying for 55,000 hours. So if we can replace even 10 million clay-fired bricks, it's a huge reduction, a huge impact to reduce our carbon emissions just in the built environment. I won't go too much into this, obviously, but this is a good shout out just for the team. Obviously, Gabi and I are here today. We have a chairman, Andrew Hosty, who used to be a COO of Morgan Advanced Materials, so a huge ceramics company, but he's been desperate to make his impact on sustainability, and he's joined the company, and he was also at the Sir Henry Royce Institute, which is kind of Europe's largest institute in Manchester. And indeed, he was president of CIRAM, which became Lucidian, one of the largest test houses for building materials in the UK. So again, just to add a bit of weight to the team that have been developing this. And again, shout out to our current employees. And we'll be bringing on another 3 members of the team over the next 18 months, which is another exciting part of our journey. Just some of the kind of recent support that we've had. We're in SEPA's housing plan. I think we're the only named product in their housing plan for sustainability. So again, really exciting for us, but also, again, to highlight what we've heard today, materials and products are out there, and we're just desperate to keep encouraging the companies out there to use our product. And quick shout-outs, obviously, to the Construction Scotland Innovation Centre, to Scottish Enterprise, Interface Scotland, Zero Waste Scotland, and the Royal Academy of Engineering for supporting us to date, because it has been a long journey. But now we're really looking to the future and to kick on. And obviously, some of the achievements and press and awards that we've received along the way. It's amazing that a brick can excite so many people. When we started this, we weren't quite sure. And here's a quick photograph of a recent project that we were involved in at Hampton Court Flower Show, where they used our brick slip, our long, slender profile brick slip, and also just, again, some of the awards there. But everybody, thank you very much for listening to us today, and again, thank you to the Innovation Centre.